Hello, everyone. In this video, I want to explain how to add vectors together using the graphical method. So first of all, a vector is a quantity that has both magnitude and direction. So many of the quantities that we look at in this physics course, things like displacement, velocity, acceleration, force, which we'll talk about in this lab on additional vectors, torques, etc. Those are all quantities that can be represented as vectors. So they both have a magnitude and a direction. Now, when we write a vector, for instance, if you want to write the vector f, typically it's done two different ways. If it's in a textbook, usually it's boldface. So that would represent like the vector f. Or if you're drawing it by hand, you would write f and then put an arrow over it to represent the fact that it's actually a vector. Okay, so either boldface or you can draw an arrow over the name of the vector, in this case, vector f. Graphically, vectors are basically represented as arrows, right? Or directed line segments. You can think of it as an arrow. So in this case, we have, a standard coordinate system here, and we have a vector f that's drawn from the origin. So the tail of this vector, the tail of this arrow, right, is at the origin, and the tip is out here. The length of this arrow represents the magnitude of f. So the length is going to be the magnitude. And then the direction is simply the orientation. But in this case, since we have a coordinate system, the direction is given by this angle theta. And usually we measure the angle always from the positive x-axis counterclockwise, right? And that would be the direction theta. So like for in a second quadrant, it would be, between 90 and 180 degrees. It'd be over here. We're in the third quadrant, it'd be between 180 and 270 and so on. In the first quadrant, it's an angle between 0 and 90 degrees. So it's from the positive x-axis counterclockwise. So how do we add two vectors together graphically? So let's say I have two vectors, and I'm going to name them A and B. So again, mathematically, the only thing that's important is that it has a magnitude, right, given by its length, and a direction given by the orientation of the vector itself, which you can measure using an angle if you had a coordinate system. So if I want to add A and B together, typically what you do, and this is called the triangle method, we'll teach you two different methods. We're mostly going to use a triangle method. Typically what you do is you start with a Cartesian coordinate system, so the standard XY coordinate system, and I take that vector A and I slide it. So I'm maintaining the same length, same direction, same orientation. I'm sliding it so that the tail of A is at the origin of the coordinate system. So now A looks like this. I just took this vector and slid it down here. Then I take the second vector that I want to add to A, which is B, and I slide vector B so that the tail of B is at the tip, right, the arrowhead of A. So we sometimes call this tip to tail, this triangle method. So I'm sliding B now, so its tail is at the tip of A. And then finally, to get the resultant, so the sum of these two, the sum of A plus B, those two vectors, we're calling R for resultant vector. Sometimes people use S for sum. There's different ways you can name it. To get that resultant vector, I simply draw a vector, draw an arrow, starting at the tail of the first vector, so the tail of A, which is at the origin in this case, to the tip of the last vector, in this case, the tip of the second vector, which is B. So this vector right here would be vector A plus vector B. And notice that I could measure the angle here for R, so it has a direction, and I could measure the length of this and would have a magnitude. Okay, so that's a triangle method. Another way that you could add vectors, and it's very similar, it's slightly different, it's called the parallelogram method. In this case, what you would do is, again, you would start with a Cartesian coordinate system, and now you would slide both vectors, A and B, so that their tails are at the origin. So think of A being slid down here, its tails at the origin, and I also slide B, so its tails at the origin. Then basically what you do is you complete the parallelogram. I draw a side, so this is like dashed, and it's parallel to A, right? And it's the same length dashed in here. And I draw a side that's parallel to B, same length dashed in here. And then if I draw a vector from the origin to the other side of that diagonal, so here's my R, that's again going to be A plus B. That's going to be my resultant vector. It's going to be the sum of A and B. So sometimes people don't like to use parallelogram method because it's a little bit more work. But the nice thing about it is you can see that the order in which you add vectors doesn't matter. For instance, if I start with A, you can really think of this as B, right? This would be the tail of B, tip of B, and I add B, I get R. Or I could start with B, so B's first, and then this would be the tail of A. So I'm putting the tail of A at the tip of B, and again, I get R. So the order in which you add vectors doesn't matter. It has that commutative property. A plus B is the same as B plus A. Let me show you this, these two techniques again, using a simulation from PHET. Okay, so same exact thing. I just want to show you using the simulation. Let's say I have a vector A here. It has a magnitude of 11.2, whatever it may be. Let's say it's a force, let's say it's newtons, and its direction is 26.6 degrees. So again, that's from the positive x-axis counterclockwise. And then I have a vector B here. It has a magnitude of 10.8 newtons, and its direction, its angle is 68.2 degrees. And I want to add A and B together to get a resultant vector. So again, we start with, you could start with either, but let's start with A. And I'm going to slide it so that the tail of A is at the origin of the coordinate system. Then I go to vector B and I slide B so that the tail of B is at the tip of A. And then finally, if I draw a vector from the origin to the tip of B, that's going to be my resultant vector. And actually in the simulation, if I click on sum, it'll do that for me. I'll just slide it down so the tail of vector, in this case, we're calling it S. We usually call it R for resultant, but this is S for sum. So the tail of S is at the origin and the tip of S is at the tip of B. So that S there is the same as vector A plus vector B. Okay, in this example, let's say I have this blue vector, call it vector A, and I have this orange vector, vector B, and I want to add them together, but using the parallelogram method. So remember now I'm going to slide these so that their tails are both at the origin. So that's at the origin, And then I draw a side parallel to B, right? In the same length. So I did that here. Let me just connect it. And then I draw a side parallel. Sorry, I guess I call this A, right? So blue. So this is parallel to A, same length. And now for the B, the orange one, I draw one the parallel to B, same length. Dash in there. And then if I draw a vector from the origin to the other side of the diagonal, that's going to be my resultant vector. So A plus B, this blue plus the orange, I don't have any other colors, gives me this resultant vector or the sum vector, which is in blue here, right? It's sort of the same as the triangle method, except instead of forming a triangle, you're actually forming a parallelogram, but very similar. Triangle method really is the quick and easy way to add two vectors together. And that's what we're going to emphasize in lab. But just so you're familiar with it, parallelogram method is sometimes used. Okay, now what if we want to add more than two vectors together? Let's say we want to add three vectors together, A, B, and C. You really are doing the same process. You're just adding those vectors tip to tail. Now, because the resultant figure at the end when you do this is going to be a polygon, we typically call this the polygon method, but it's nothing more than continue to add the vectors tip to tail. So in this case, I would start with A, right, wherever it is, slide it so that the tail of A is at the origin. Then I'm going to take B, slide it so the tail of B is at the tip of A. Then I take C and slide it so the tail of C is at the tip of B. And then finally, if I draw a vector from the origin, from the tail of A to the tip of the last one, in this case, tip of C, that's going to be A plus B plus C. That's my resultant vector here, R. Okay, actually, let me show you this in the simulation as well. Okay, so in this example, I want to add vector A plus vector B plus vector C. So vector A has a magnitude of 12.1, whatever the units are. It could be, if it's a velocity, it's meters per second. If it's a force, it's newtons, right? Mathematically, we would just say 12.1 units, whatever they are. Let's say it's a force, so 12.1 newtons. It has a direction, 24.4 degrees. Then I have vector B, it's sort of pointing towards the second quadrant, right? So it has a magnitude of 24.2 newtons, and it has an angle of 155.6 degrees. And then vector C is pointing straight down. So in this case, it has a magnitude of 8.0 newtons. And you could either, so if we go counterclockwise, this would be 270 degrees. Or another convention is if we measure clockwise, we say it's negative. So this would be like negative 90, right? So it's either positive 270 or negative 90, same thing. So again, to add these three together, I have to first start with one of them. It doesn't matter what order I do this. Let me start with A. Then I move the tail of B to the tip of A. And then the tail of C to the tip of B. And then finally, if I draw a vector from the tail of A, which is the origin, to the tip of the last one, tip of C, that's going to be my resultant vector. And in this case, if I add vector A plus vector B plus vector C, I get a vector which has a magnitude of 13.0 newtons, and it has an angle, I guess, of 147.5 degrees, right? So this is, again, they're calling it S, but this is what we call R, vector R, resultant vector. Okay, and the order didn't matter, right? So here, let me actually just do this in a different order. Let's say I start with B, then I add C, and then I add A. And you're going to find you get exactly the same vector, right? It's 13.0 and it's 100, and it's hard to read here because it overlapped the numbers, but it's 147, the same as it was before. So the order in which you add vectors doesn't matter. Now, when you guys do this in lab, let me just switch these. Let me put A here and C here. When you do these in lab, you're going to measure the length of the vector using a ruler. And then if you have a conversion factor, for instance, if you know so many centimeters is equal to a newton, then you can, by making these a particular length, that'll represent the magnitude in newtons, because you have a conversion factor. And then the angle you're simply going to measure with a protractor, right, when you add these in lab. Okay, great. So hopefully that was helpful. Again, this is like graphically adding vectors together. Thanks.